Here we go. First hour, let's go. We have this relation right here, x and y values. And what we want to do is we want to determine whether or not it's a function. We're going to express it multiple ways. First of all, the domain remembers the x values, and they are in order from least to greatest. So -3, -1, 1, and 3. Are the y values already in order for the range? Yes. So we just have 2, 5, 8, and 11. Now, one way we can determine whether or not it is a function is by looking at the graph. So I'm going to plot these points, -3, +2, -1, +5, 1, +8, 3, +11. Do I ever have one point stacked directly on top of another point? No. As long as you don't have 2 points stacked on top of each other, it is a function. The other way we could tell it's a function is by looking at the mapping. Notice that our domain in this situation is -3, -1, 1, and 3. What y value does -3 belong to? What y value does -1 belong to? We have 8 and 11. Notice how each domain just goes to one range value. That's another way to see that it is a function. So let's look at number 3. Do you think number 3 is a function? Yes or no? Why? Very good. So yes, it's a function. I would like to list the domain and the range and fill in the rest of these just to make sure we got our point correct. What is the coordinate here? -5, 3. Looks like my next coordinate is -2, +1. What's the next coordinate? 1, -1, and 4, -3. Are the x values, the domain, are they already in ascending order? Yeah, they are. So I can list -5, -2, 1, and 4. Are the y values in ascending order? No. So you list them in ascending order: -3, -1, 1, and 3. Ascending means going from least to greatest, as opposed to descending. So we have our domain and our range. We're going to map these really quick. -5, -2, 1, and 4. And then range -3, -1, 1, and 3. What does -5 belong to? Belongs to +3. What does -2 belong to? And 1 belongs to -1, and 4 belongs to -3. So is it okay to be a function and have the lines cross like that? Yeah, it is. As long as you don't have more than one line coming from a domain value. So last one, and then I'll give you time to work, is number 4 a function? Why? 7 goes to 2 different locations. 7 goes to -1 and to 0. That would be like saying player 7 scored -1 points in a game and player 7 scored 0 points in a game. So no, this is not a function. Notice if you were to list your points, as Maya said, it would be 7 and -1, and it would be 7 and 0. Notice how 7 gets listed twice. We have 9, -7. We have 12, -1. And we have 15, 0. You don't list the numbers twice for the domain and range. So your domain is 7, 9, 12, and 15. Notice your domain sits right over here and your range sits right over there. So your range is -7, -1, and 0. Is it okay to have fewer numbers in the range than in the domain? Yeah, I brought this example up yesterday. Are neither of these functions? Is one of them a function, or are they both functions? Very good. Which one is a function, the top or bottom? The bottom one. It's okay for player 1, 2, 3, and 4 to all score 1 point in a game. That works out. That makes sense. This is a function. However, player 1 can't score 1, 2, 3, and 4 goals in a game. You would say you got to choose which one it is. Very good. So as we end this right here, I just want to make sure that we show this last piece, which is if I were to plot, I'm just going to write the number 7. If we were to plot some of these like 7, -1, and 7, 0, notice how those are right on top of each other, which again shows that it is not a function. We all clear on that? Okay. Very good. So today, you're just going to try to identify those pieces and decide whether or not it is a function. And tomorrow, I'll have the rest of the notes ready to go for the unit and things kind of wrapped up for where we'll be for the rest of the year.